Hey guys, this is Mr. Lowry. I'm just going to go through this Unit 1 practice test with you. I want to give you some hints and um, just some ideas of what you can expect on the actual test. So this is going to be kind of my scratch work up here. I'm going to show you what I'm writing here, but I also wanted to be able to um, have you see my screen. So I'm going to go ahead and jump into this quiz. This is the Unit 1 practice test. Okay. Um, The first question is about number sets. So it's asking every rational number is also an integer. Well, we have to kind of go back and think about the number sets for a second. And if you remember from one of the videos I showed you, we had a Venn diagram. And in that Venn diagram, we had like all the real numbers. And the real numbers can kind of get broken up into two categories that don't overlap. And in these categories, we have the rational numbers, and then we have irrational numbers. Okay. Irrational numbers are non-repeating, non-terminating decimals. You actually can't write them as fractions. So things like pi, square root of 2, e, those are all irrational numbers. The rational numbers are numbers that can be written as fractions. So you have stuff like 3/4, right? 1/2, okay? Now included in the rational numbers are all the integers, right? Because integers can also be written as fractions. So rational number is any number that can be written as the ratio of two integers. So 3/4 is the ratio of two integers. 1/2 is the ratio of two integers. But each integer, like 3, can also be written as the ratio of two integers because we can write it as 3/1, right? So the deal is that every integer is rational, but not every rational is an integer. Because of course 3/4 is not an integer, right? And 1/2 is not an integer. So that's kind of what's going on here. So every rational number is also an integer. That's false because 1/2 is not an integer, and 3/4 is not an integer, and 7/9 is not an integer, right? So there's numbers out here that are rational, but that are not integers. However, every integer will be rational, right? Because like 2, for example, that's 2/1, and -5 is -5/1. So once again, every integer is a rational number, but not every rational number is an integer. So this is going to be false here. All right. Which of the following classifications apply to the number below? Okay, so square root of 2 is irrational. It's one of those in-between square roots, right? Like if we had square root of 4, that's fine. That's rational because that's 2. And square root of 9, that's fine. That's rational because that is 3. And the square root of 1, of course, is 1. So those are actually all rational numbers. Square root of 2 is in between here. It actually comes out to about 1.41 or so. But the in-between square roots, the ones that don't come out nice, are irrational numbers. But keep in mind that all the irrational numbers are also real numbers. So not only is this number irrational, it's also real. So I'm going to check both of those. Now, imaginary is another set. Imaginary numbers actually exists outside of the real numbers. There's I guess a different relationship between reals and imaginaries. We haven't talked about imaginaries yet, but this guy right here is a irrational and it's a real. So don't worry too much about imaginary. That's kind of a distractor that we haven't really talked about yet. Okay, this next one here is about basically about exact answers. Okay, so at the beginning of the semester, we talked about these different number sets, and we also talked about how do we write an exact answer. Now, remember that pi is irrational. So any time you use a pi key and you get a decimal, that's going to be an approximation because pi can't really be written as a decimal. It's a non-terminating, non-repeating decimal, and so we can't ever really write it. So this this question is asking you for the volume of a cone. So the volume formula for a cone is V equals pi r squared h over 3, where V is for volume, so V is for volume, R is for radius, for the base of the cone, and H represents height. So this isn't really super important in terms of what we're talking about, like with the cone. The cone formula is not important. I'll just give that to you. Okay, but we got radius, right? We got height. The real thing we're worried about here is figuring out how to write exact answers, okay? That's kind of what we're after. So if we're using pi, which is an irrational number, an exact answer won't have a decimal approximation in it, okay? So let's take a look at this guy here. We want to find the formula, or we want to use the formula for the volume to find the volume of a cone has a base of 5, a base radius of 5, and a height of 9. So that's saying that R is 5 and H is 9. Okay, all we're going to do is plug that into the formula. So I have pi times 5 squared times 9 over 3. Okay. And the trick here is that we want to simplify as much as possible, but we don't want to turn our fraction into a decimal, and we don't want to use pi at all either. So let's just simplify, okay? Well, if you think about 9, 9 is 3 times 3, right? And 3 goes into 9. So we can just like start canceling stuff right off the bat here before we start multiplying. 3 goes into 9 3 times. And so what we're left with is pi times 25 times 3, because 5 squared is 25. And that's just 75 pi. Now, since we're talking about volume, we should be talking about centimeters cubed. Actually, this is kind of a typo. These centimeters squared should be centimeters cubed. So I'll go back and fix that for you. Oh, sorry. Volume. Okay. Yeah, these should be centimeters cubed. So I'll go back and fix that for you. But the idea here, the main idea, is talking about exact answers, okay? So when we're looking for this one has pi in it, 225 pi centimeters. This one is a decimal approximation. This one, although it looks tempting to say, oh, that's probably exact because it has the most decimals, we're never going to have an exact answer if we're using pi as a decimal. It just can't happen. And so you have to leave your answer in terms of pi. So this is our exact answer here, right? 75 pi. And if you notice, there's no 75 pi as an option. So this is a distractor. These are not exact answers because, again, we're using pi. These decimal approximations won't work. And so we got to choose this guy. None of the other answers are correct. Right. Okay. Next one here, we're using properties of real numbers, and we want to get common denominators. So the other topic that we want to talk about is properties of real numbers, okay? So when you're trying to get common denominators, the way you do that is you multiply the top and the bottom of a fraction by the same number. So in this case, we have like 2 over 2, right? 3 over 3 and 4 over 4. When we do that, we're going to get these common denominators of 24, which is what we want. That's kind of the whole idea. But this 2 over 2, remember, is just 1. And this 3 over 3 is just 1. And this 4 over 4 is just 1. So what we're doing is we're multiplying by 1 to get something equivalent, okay? The identity property of multiplication says that anything times 1 is equal to itself. That's what the identity property looks like, okay? So if you have, 5 over 12 times 1, that's going to give you 5 over 12, okay? That's pretty obvious. But what we're doing here is we got 5 over 12 times 2 over 2. But remember that 2 over 2 is just 1. So really we're multiplying by a fancy one, or by a form of 1, to get this guy. Now, since we're multiplying by 1, the identity property says that these have to be equivalent fractions. Okay, these have to be the same. Okay, so that means that 10 over 24, this guy, is the same as 5 over 12. So whenever you're getting common denominators and you're using this technique of multiplying the top by 2 and the bottom by 2, the top by 3 and the bottom by 3, the top by 4 and bottom by 4, you're really multiplying by 1, and that is using the identity property of multiplication or the multiplicative identity property. Okay, there's not really a such thing as a common denominator property. That's a distractor. Distributive property of multiplication, that's something else. And the multiplication property of equality we're going to use on a future problem. Okay. All right. Number 5. Let's get this out of the way a little bit. What property of real numbers is being used to justify the change from step 2 to step 1 to step 2, excuse me. So you'll notice this is the same equation that we had before, but there's 2 different techniques that we talked about for solving stuff like this, right? One of them is to get common denominators, 24, 24, 24. The other one is to clear the denominator altogether, okay? So in this case, we find the lowest common denominator or the lowest common multiple of 12 and 6 and 8, and it's 24. And then we multiply both sides by 24, okay? What's going to happen in a minute, it hasn't happened yet, what happens in just a second, or what the next step would be to kind of write this out, and we're going to have 7x over 8 equals 1 over 6 times 24. So we'd have to distribute that 24, and then we're going to cancel, 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 and we're going to get left with 2 times 5, which is 10, minus 3 times 7x, which is 21x, and then 1 times 4. Okay, so this is where we would get, that's what we're doing here. But the property that we're using in this step is the multiplication property of equality. The idea that if we multiply the left side by 24 and we multiply by the right side by 24, then this equation is still true. Now remember, we can only use a property of equality if we have an equal sign, if we have an actual equation, which is what this is. So question 5 and question 4 are 2 different strategies for solving the same problem. The property that we're using here is the multiplication property of equality, okay? It's not the identity property, that's what we used up on the previous one. It's not the symmetric property of equality, that's something different. Symmetric property of equality says if you have x equals 3, that's the same as 3 equals x, and you can kind of swap the order of those, right? But that's not what's going on here. Commutative property of multiplication says the order that you multiply in doesn't matter. So it's not any of those guys, it's this guy, multiplication property of equality. Now later we're going to have to distribute, of course, but we haven't distributed yet. This right here is just the multiplication property of equality. All right, now this guy here is basically that same kind of idea. We're going to solve this equation, and we're going to use that technique of clearing the fraction. Okay, so the first thing we need to do, step 1, is we need to find the lowest common denominator. So we got a 30, a 10, and a 6, and they all go into 30, right? 30 goes into 30, 10 goes into 30 3 times, and 6 goes into 30 5 times. So that's the lowest common denominator. Okay. Now what we're going to do is we're going to use the multiplication property of equality, and we're going to multiply both sides by the lowest common denominator, which in this case is 30. So what we're going to have here is 5x minus 2 over 30 minus x plus 2 over 10 equals 1 over 6. And we're going to do a big one of these. Okay, multiply by 30 on both sides. Again, just like we talked about in the last problem, that's the multiplication property of equality. Okay, so step 3 is to distribute, because we don't want to cancel anything yet. We don't want to cancel those 30s yet, although it's kind of tempting. We need to distribute the lowest common denominator, because 30 doesn't just multiply this guy, it also multiplies this guy. And so we can't cancel it until it multiplies both pieces. So we have 30 times 5x minus 2 over 30 minus 30 times x plus 2 over 10, and then equals 1 over 6 times 30. Now, probably one of the things that I should have done initially is circled this guy, because if we have a subtraction, that's going to have to distribute over these two terms. So let's keep in mind that's going to be an issue. Okay, step 4, we need to cross cancel. This is the fun part where we get to kind of make, it feels like we're making a lot of progress. 30 over 30, that's going to cancel. 10 goes into 30 3 times, and then 6 goes into 30 5 times. Step 5 is to finish multiplying whatever is left. Okay, so we have just 5x minus 2. Okay, now remember that minus sign that we circled before? This is a negative 3 distributed over x plus 2. So we have to distribute the negative with the 3. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6x. And if you didn't distribute, you wouldn't get that minus 6, and that would throw you off for the rest of the problem. All right, now all we got to do is just finish solving the equation, which is pretty easy. Combine like terms and solve. So I'm going to say CLT, combine like terms, and solve. So we got 5x minus 3x. That's going to be a 2x. Combine those two guys. Now remember, because they're on the same side of the equal sign, we're doing combine like terms. So just make sure that you don't try to like add 3x and add 3x. That's not going to work because they're on the same side. All right, we'll add 8. We'll add 8. Okay, so 2x is equal to 13, and we'll divide by 2. 13 over 2. Now, some of you guys are like, oh, that's 6.5. That's true. It is equivalent to 6.5. The idea here in Algebra 2, or SM2, I guess, is we like fractions. I know some of you guys are not used to using fractions or don't like fractions, but fractions are exact answers. Now, 6.5 is also an exact answer, and so that, would be an exact answer in this case. But sometimes you don't have exact answers. So for example, what if I had 2 over 3? Well, if I wanted to turn that into a fraction, that would be 0.66667, which is actually, this is just a decimal approximation, okay? So we prefer using fractions. If your equation starts with fractions, you should end with a fraction, okay? I also want to make sure that you can do fractions, because some of you guys will like just turn this into decimals and go from there. But we really want to get used to doing this without a calculator. We want to get used to using fractions and being comfortable with fractions as we go forward, because that's gonna it's going to be a whole lot better in terms of exact answers. So in this case, it says your answer should be a simplified improper fraction. Okay, if you put a decimal in for this problem, you're going to get it wrong. And I was really clear on exactly how I wanted you to put your answer. You don't have to put an x equals in. I just wanted to avoid kind of some of the problems with the fill in the blank, because I know sometimes people put extra spaces in and it messes it up. So we're going to keep it real simple and just put the fraction. Okay, simplified improper fraction is what we want there. All right, this guy just goes back to the negative exponent property, okay? So evaluate, the word evaluate means give me a value. Your answer should be a number, okay? So 3 to the negative 3, well, first of all, we don't want any negative exponents, okay? That's not simplified. So if we change this, we know that this is 1 over 3 squared, right? If we use our little analogy, the bad parent analogy, this little 3 has like a negative thought bubble, so we're going to send him down to the basement, right? You think about this as a fraction. When we send this guy down to the basement, there still has to be something left on top as a placeholder, and that's going to be 1, which is the multiplicative identity. Sorry, this should be 3 to the 3rd. So that's kind of how we deal with the negative exponent. Now, we want to evaluate, right? So we're not done yet. If this was a letter or a variable, sure, we'd be done, okay? But this is a 3 to the 3rd, and we know what that number is. We can actually figure that out. 3 to the 3rd is 3 times 3 times 3, which is 27. So this is 1 over 27. Evaluate means give me a number value. So your answer to an evaluate question should be a number. In this case, it's a fraction. We don't want negative exponents because that's not simplified. We don't want to leave 3 to the 3rd when that's something we can actually do. We can take 3 to the 3rd. So eval, that's what this evaluate means, okay? Also, we don't want to turn this into a decimal. We don't want to throw this in our calculator and then get some decimal approximation. That's not what we want. We want an exact answer, okay, 1/27. So you're probably starting to see a theme when we're talking about exact answers here. We're talking about simplified fractions. If we're talking about pi or irrational numbers, we need to leave those irrational numbers and not multiply them through. Okay, so that's one of the big things that we need to get used to in SM2 to get better at algebra, is to talk about fractions and irrational numbers and not go to decimals. All right, now we're getting into more of the properties of exponents realm, okay? So there's more than one way to solve these properties of exponents problems. I gave you guys kind of a list of kind of an order of operations. But kind of one of the main ideas is, first, you want to look for anything that doesn't have a power on it, and then change that to a power of 1, because that will help you avoid some mistakes. So when I have this, I'm going to go 6 to the 1. I also might go -4 to the 1 power, like that. Okay, so those are the rest of the stuff that I have. Also, we should notice that this is a multiply by -4. This isn't subtracting 4. This is multiplying by -4. So putting that kind of in parentheses here with the little dot, we're multiplying, so don't get confused there. It looks like kind of like a subtraction, but that's not what's going on. All right, so what I'm going to do here is I'm going to use my product property first. I got some negative exponents, and it's tempting to want to move those, but we may not need to. So I'm going to use my commutative property to rearrange this guy. So 6 to the 1 times -4 to the 1. Okay, not 6 minus 4, 6 times -4. Okay, and then x to the 5th times x to the -3, y to the -3 times y squared. So now everything's matched up. These here are going to multiply to give me -24. Okay, don't put 2 there. Don't fall into that trap. Okay, it's 6 times -4, so don't mess that up. Okay, now here we're going to add the exponents. So 5 plus -3 is x to the 2. Okay, and then we have y times y, so we're going to add the exponents here again. That's the product of powers. That's going to give us y to the -1. Okay. All right, so we're almost done. We don't have any other weird, parentheses. We don't have any other powers to multiply through or anything like that. The only thing we got to do now is take care of this guy. So the y to the negative exponent, we don't want to have negative exponents in our final answer. So what we're going to do is we're going to send that guy down to the basement. And it's going to become y to the +1. And we don't really need that 1 there, so we're not going to put it. This is another common thing that people want to do. When we talk about this negative exponent property, and you're like, oh, if you move that down to the bottom, the exponent becomes positive. We talked about why that was. Basically, a -3 is like all the y's cancel, but there were 3 on the bottom or something like that. So negative exponents turn into fractions. But a lot of times people want to take this -24 as a number and move it downstairs. Doesn't work for numbers, right? It only works for exponents. It doesn't make sense to say like, oh, I got -3. That's the same thing as 1/3. No, we obviously know that those aren't the same thing, right? That doesn't work. Okay, so there's a reason why it works for exponents, which we kind of explained with the negative exponent property. But you don't need to worry about that negative. That's not a negative exponent. That's just a negative number, and that's fine. So this is where we're at. -24x squared over y. Okay. This one is I'm going to use the quotient rule and some power properties. Again, the thing I would do maybe first is go through and look for things that don't have an exponent. Give them an exponent of 1. The other thing I would do that I didn't mention in the previous problem was look for things that are powers of 0. In that last one, we didn't have those, so we didn't have to worry about it. And here we don't either. In this type of problem, what you're going to want to do here is you want to look inside the parentheses first. You want to simplify inside the parentheses. Now we could kind of use the product of power and the product of quotient property and start multiplying all these exponents. But that's going to be a lot of work because we don't want to do 12 squared over 8 squared. That would be hard to simplify, right? And we don't want to do 4 times 2 and 6 times 2 and then simplify it later. The real key here is to simplify inside the parentheses as much as possible first using our product and our quotient rule. Let's start with the fraction, right? That's just 12 over 8. It's a regular 12 over 8, right? Just a fraction. 4 goes into both of them, and so we're going to get 3 over 2. All right, now we're going to use the quotient property for our x's. We got x's over x's. So we're just going to have x to the 4 minus 6. Whenever you use the quotient property, the quotient rule, the number lands on, or the variable, excuse me, lands on top. It may move later, but initially we're going to put that variable on top. Okay, and then we have y to the 3 minus 2, right? Same idea, y goes on top. We have 3 minus 2, all to the second power. Okay, so then we got 3x to the negative 2, y to the 1, all over 2, to the 2 power. Now remember, again, this is 3 to the 1 and 2 to the 1. A lot of people, they call this distribution, right? Distribute the 2. I try not to call this distribution, or if I do say distribution, I like to say quote unquote distribution, because it's not really distribution. It's the power of a product and the power of a quotient property, okay? But the exponents are going to multiply, but don't do 2 times 3 and get 6 and 2 times 2 and get 4. That's not what we're after. We want 3 to the 1 times 2, so 3 squared, not 3 times 2, 3 squared, which is 9, not 6. Okay. Then we are going to have the x to the negative 4. Okay, we're going to have y to the 2 times 1, which is 2, and then we're going to have 2 to the 1 times 2. Okay, now when everything is all said and done, now the exponents aren't changing. So we changed them a bunch of times. We changed the exponents when we subtracted, we changed the exponents when we multiply, but now that they're not done, now that they're done changing and they're not going to change anymore, now we'll use our negative exponent property and we'll just fix anything that has a negative exponent on it. Oh, sorry. When we move that downstairs, that becomes a positive 4. That was the whole point. All right. So the last thing we're going to do is just evaluate any of the numbers to powers, right? So we got 3 squared, that's 9. We got 2 squared, that's 4. We got y squared, and then we got x to the 4th. Okay, so let's see if we can find one answer that looks like that. Looks like that guy. All right, now this guy's going to be basically the same thing. The only difference is you have a bunch of negative exponents. So don't let that trip you up too much. Again, there's more than one way to go about this. And if you have your own preferred method, that's fine. More power to you. Get it? Powers? Funny. But I'm going to show you the way that I kind of do it every time. If you want to get creative and find, different ways to do different problems, sometimes that's helpful. But I kind of like to, when I teach this at least, I like to stick to one way of doing it every single time until, you guys get better at it. All right, so again, the moral of the story here, the most important thing is to simplify inside the parentheses. We can add our powers of 1 if we want. Look for our powers of 0. There aren't any, right? So we start inside the parentheses and we do everything we can inside the parentheses to simplify, starting with the fraction. Okay, we know that 9 goes into both of those. That's like the biggest thing that goes into both of those. 9 goes into 36 4 times, and 9 goes into 27 3 times. So that's just a 4 over 3. Okay, now we're going to use the quotient rule with the x's. So we're going to have x to the 6 minus negative 2. Quotient rule says I need to subtract because I have x's over x's. But since this is already negative, I'm going to have 6 minus negative 2. We'll take care of that in a minute, but just let's not get thrown off by that, okay? Then we're going to have the y's. So y's on top again. Negative 4 minus negative 3. All right, and then all that to the 2 power. And if I want, I can put a 1 and a 1 back there on the 4 and the 3. All right, so I'm going to have 4. This is going to be 6 plus 2, right? The minus minus is going to turn into a plus. So that's 4x to the 8, or 4 to the 1x to the 8. Same thing's going to happen here, right? That's going to be a plus. It's going to be a plus. So I have -4 plus 3, which is y to the -1. That's all over 3. Okay, now everything inside the parentheses is as simple as it's going to get. So now I'm going to use my power of a product and power of a quotient, which a lot of times we like to think of as distribution, right? It's not, but we're going to start multiplying these powers by 2. So it kind of looks like distribution, even though it's not. So 4 to the 1 times 2. Now don't put an 8 here. This is not 8. It's not 2 times 4 because it's not distribution. It's the power of a product. So we have 1 times 2. 4 to the 1 times 2. 4 squared. So we want a 16 there, not an 8. All right, then we have x to the 8 times 2, x to the 16th. All right, then we have y to the -1 times 2. So y to the -2. Okay. And then we can't forget the guy on the bottom, 3 to the 1 times 2. Again, that's not 6. Very common mistake to say 2 times 3 is 6. It's not 2 times 3. It's 3 to the 1 times 2. It's 3 squared, which is not 6. It's 9. All right, so we got 4 squared, x to the 16th, y to the -2. We're going to move that guy downstairs and make it a +2. And then the last step is going to take those two exponents, the 4 squared, and make it a 16. And the 3 squared is going to be a 9. And we'll make sure we have positive exponents. Sorry. So 16x to the 16th, 9y over 9y squared. Okay, almost there. Hang in there with me. All right. Now this guy does have a bunch of zeros, or it has a couple of 0 exponents. So the point is anything raised to the 0 power is 1. But we got to figure out exactly what is being raised to the 0 power. Okay. So when we're doing these guys, the first thing, again, I would always do is start adding powers of 1 where you don't see them. Okay. The reason why that's important, especially in this case, is because we want to see that like this x is not being taken to the power of 0. And this 3 is not being taken up to the power of 0. And if you just write 3xy 0, you might get confused and think that all of those things are being taken to the 0 power, and they're not. It's just the y. Now over here, in this case, all this stuff, this whole chunk is being taken to the 0 power. So the 0 product, or the 0 exponent property says anything to the 0 power is 1. Boom, so there's a 1. That whole chunk is a 1. Okay, now this guy here, we have a y to the 0, so we can make that a 1 as well. So let's cross that out. That's just 1, right? And since we're multiplying 1 times something isn't going to change it, we don't even really need to write that 1. This is just 1 times whatever this is. Okay, so this is going to be 3 to the 1, x to the 1, y to the 0. Again, that's just 1. And 3 times x times 1 is just 3 times x. We still got that 2 in there. All right, so we want to take 3 to the power of 2 and x to the power of 2 using our power of a product and power to power. And this is going to be 9x squared because 3 squared is 9. I know I've been harping on this a lot, but I want to make sure nobody makes this mistake because it's really, really common. This is not 2 times 3. Don't put a 6 there, please, or I'll make fun of you. Just kidding, I won't. But don't fall into that trap, okay? That's why we put the 1s on there in the first place. But again, as much as this looks like distribution, it's not the distribution property. It's not distribution. It's the power of a product and power to power properties. Okay, that's what we're after. All right, last one. Okay, now this is kind of a funny question, and I guess you could say it's a trick question. I don't like really believe in trick questions, but what I do believe in is testing your knowledge of important concepts. Okay. So this either is a very scary problem or a very easy problem for you. When you look at all this junk right here, you're like, holy smokes, that's a lot of stuff, okay? If we go through our steps that we talked about in class, step 1 was to put 1s on stuff that doesn't have exponents. So I would do like 2 to the 1, 4 to the 1, m to the 1, 8 to the 1, q to the 1, okay? The very next step, step 2, is look for your powers of 0, because you can get rid of a lot of stuff that way. And in this case, this is just one whole chunk to the power of 0. And the 0 exponent property says anything to the 0 power is 1. So this whole ugly mess is 1. The answer is 1 here. Okay, now if you go down here and you look for that, 0, 1 over 4, and then some distractor answers that make you think that maybe you have to do a bunch of stuff in here, you don't. You don't have to do any of that. The answer is 1, right? So because we don't see that as an answer choice, I'm going to say none of the above. And so, yeah, I guess you could call it a trick question. I don't really like calling it a trick question. I'm not trying to trick you. I'm just trying to make sure that you understand how your life can be a lot easier if you do the certain properties of exponents in a certain order. And one of the early properties I would look at is the 0 exponent property, because you can get, you can make your life a whole lot easier if you look at that first. Okay, I'm gonna submit, and hopefully if I did, if I wrote my quiz right, should be have 100%. And if we didn't, then maybe I need to go back and look at some of these. So fingers crossed. Okay, 12 out of 12. Looks good. Took me 36 minutes. So, and that's with explaining everything. So I don't think this should take you very long if you understand what you're doing. If you go back and watch some of those videos, that's cool. You can do that before you take your test, of course. That's a good study technique. Go back and look at your notes, okay? So you can look at some of these things, and now the questions on the actual test are not going to be exactly the same. So they're going to be similar, though. They're going to kind of cover similar concepts. But the reason why I say they're not exactly the same is because the wording might be slightly different. It's going to be a similar concept or a similar problem, but things are going to get tweaked. The idea is to, give you an example of what you can expect, but I might answer this question. I might ask this question a different way. I might say something like, true or false. Every whole number is an integer. And you might say, yeah, that's true. Or I might say something like, every integer is a whole number. And you might say, well, -3 is an integer, but it's not a whole number, so that's false. So the idea here is don't try to memorize the answers. Try to understand concepts. Concept that we're talking about here is that Venn diagram with number sets. If you understand that Venn diagram, then you can answer questions like this. Right? Same thing here. Don't memorize that square root of 2 is irrational and real. Understand what an irrational number is. Understand that every irrational number is also real. Understand that there's another set of numbers called rational numbers. Because I might ask you a question with something else like, what's the classification for 1 over 3? And you might say, well, that's rational and it's real. Or I might say something like, what about 3? And you might say, well, that's a whole number, and it's a natural number, and it's a rational number, and it's an integer, and it's a real number, right? So again, don't try to memorize the question. Try to understand what all these things are and how they relate to each other. And if you want to go back and watch that video about number sets, you can go back and find that video from the day that we did that. Same thing here, right? The idea here is not to memorize this volume formula, because I don't care about you memorizing that formula right now. What I really care about is understanding what an exact answer looks like and knowing what, again, an irrational number is and how you can represent an irrational number as an exact answer. That's the big concept. We talked about square root problems where we had like Pythagorean theorem. That was another thing we talked about. So it may not be the same formula, but again, the key is how do you write an irrational number as an exact answer? How do you write a rational number as an exact answer? Okay, again, properties of equality, properties of real numbers, excuse me. We have all these different properties, so you should understand what the distributive property is. You should know that this is not a property. You should know properties of equality, like reflexive, transitive, symmetric, right? Addition property of equality, subtraction property of equality, all those properties of equality that we talked about, you should be familiar with those. Okay, same thing here, right? I may not ask you this exact question, but it's going to be about properties and how you can use properties. when you're solving problems. Remember to read about what kind of answers I want. Don't just throw an answer in there. Read carefully about how the answer form should be, what kind of form it should look like. Understand what these words like evaluate means, and again, what kind of answer we're looking for. You're going to have similar problems to this, but it may not be exactly the same. So understand your properties of exponents and what order to do them in. Same thing here. So again, the key here I'm trying to get you to understand is, although the test will be similar to this, they're not going to be exactly the same. They're going to be pretty similar, but I can't guarantee that you can just memorize the answers and dump them over. Always more important to understand concepts than it is to like memorize answers. Understanding is better than memorizing every time. So use that as a guide. Go back to your notes, look at similar problems, look at key concepts, watch some videos. Everything from Unit 1 is fair game, but again, when I was making this test, I made it alongside this practice test, so they're going to be similar but not identical. Read the questions carefully, think about it. Don't go too fast. You're going to have 60 minutes. I mean, it's only been not even 40 minutes, and I've talked through every single one of these, so you should have plenty of time. All right, I hope that helps, and good luck on the test.